we will, we can review chapter 12 if you like.
Okay.
And later I can show you how to do the chapter 13 as well. So
Okay.
you finish chapter 12, you just continue to do your chapter 13. And these
Okay.
two need some technology to help. Do
Yeah,
you
I have
have
my
a
calculator
TI?
right here.
Do
Yes.
you have TI 84?
Yes. Yeah, I'm about to
Okay,
grab it
very
right
good.
now. One
Mm,
second.
yeah, that's great. So we can go to the chapter 12 homework and to see which question you want me to help you first. So that will help
Okay.
you to start earlier, sooner and easier. Okay.
Yeah.
So let me try to share our homework of the chapter 12. Chapter 12. So let me go. Okay. No, this one. This one. No, I think I need to open the page first. So let me go chapter 12. Okay. Okay. Do you see chapter 12 homework?
Yes,
Linear
I see it.
regression? Yeah, good. So we can take a look at this. And
Okay.
you, one of them, you think maybe you need some help. So we can stop. Um,
Mm.
which one is just a concept? Okay. Um, which of the following is a false? Can you read it? Yes?
Yeah,
No.
yes, I can see.
You can
Correlation.
see, right? Not too small.
Yeah, it's not too, I'm just a little closer, but it's okay.
Yeah. Okay. So this concept question is asking which one is false. So we had to see which one is wrong. Okay. Don't choose
Okay.
the one which is right. Because usually sometimes we just click the one we think is right.
Yeah.
Correlation coefficient and slope always have the same sign, positive or negative. Say correlation coefficient, the notation is R, small r.
Mm-hmm.
Okay. And
Yes.
the slope is the one we learned in the algebra class. Slope, the
Yeah.
steepness
So
of.
that's the like the equation of y equals
Yeah,
um
mx plus
okay.
b. Another
Yes.
m is the slope we learned in our algebra class. And in statistics, we use y equal a plus bs. And the number, that the b times the s, that the number is the slope. So just switch the s to the front to the back. And instead of use y equal ms plus b, in statistics,
Mhm.
we use y equal a plus bs. Okay, but it's the same thing. So slope is the same sign. Okay, if the r is positive, slope must be positive. Okay, same sign. So this is the correct.
Okay.
And the second
Correlation.
one, if the correlation coefficient is 1, then the slope must be 1 as well. Oh, be
Mm.
careful. If the correlation coefficient is 1, that means 100% correlated. Okay, because our R is always between the -1 and 1 only. Okay.
Yeah, I was about to ask you that because I remember last time you said it was between one and something, but it's
Yeah,
-1 and one. Okay.
that's right. But slope is not necessary to be 1, right? Slope
Yeah.
in algebra class, we have some slope is 6 or 5 or negative, whatever, greater than 1. It depends on the number given to us. Okay. But
Okay.
yeah, be careful. And number three, if the correlation between the two variables is close to 0.01, then there's very weak linear relation. Is that correct? Because the number is so
Um,
small, 0.01. When close
because
to
it's
the
supposed to be between -1 and
1,
1.
and when
So the
close to the
correlation
0, there's
between,
no correlation. Okay.
yeah.
So this one is very weak because very close to the 0. Okay. Yeah. And then uh, the correlation measures the strength of linear association between two numerical variables. That's correct. Okay. So the only thing wrong is the second one, right?
Yeah.
Because the correlation coefficient is a ratio, okay, ratio. It's only
Okay.
between -1 and 1. But the slope is comparison of the distance between the y and compared to the x, and depend the coordinate give to us. Bigger number will be bigger, small number becomes small. So it's different. Only the sign direction is same. Okay. So
Yeah.
I will choose the number 2 is wrong, false. And question 2, this point is the one we call scatter plot, right? And this one is
Hmm.
presenting a sample of the 108 college student GPA and the number of times they visit the office hour. Try to see who show up the office hour more often, their GPA is higher or not. Okay.
Okay.
Based on this scatter plot, is this true? Okay. So let's look at a horizontal line. It's presenting number of the office hour visits last semester. So the first point here shows a student visited 0 hour. Okay. Never
Hmm.
show up at the office hour. And the GPA is 2.0. Okay. The first point at the bottom here.
Okay.
Then let's look at, and there's some point on the top here. This is 1, 2, 3, 4, 5, another point here. They also 0 hour visit the office hour, but their GPA could be 3 or could be 3.5 or could be almost a 4. And even there's one student above the 4.5, must be a super student, right?
Smart. Yeah.
So we have another point like that. Then look at the office hour visit 5 times. We have student GPA up to the 4.0 here. Okay. And then let's look at the higher one. The one visit the office hour 20 hours. We have one first point here is about a 3.2 GPA. And on the top here is about the 3.7, 3.9 GPA. Okay. So look at this. There's really not something like a straight line going up like that. Because this point, the highest point on the right, compared to the left-hand side, we have same height, our point, and left-hand side is 1 point well above there. So this one, the linear correlation model is not too good, okay? Because
Yeah.
the didn't make the straight line as like from the left go the right, one line. Okay. So the choice is a concept. They're asking you. First one, the linear model is not appropriate for evaluating the relationship between GPA and the office hour. Okay.
The
Very
question was we're trying to figure out which one is true, right?
Yeah, this one is which
Okay.
one is true. And try to
Okay.
think of the linear regression. Okay. The
Okay.
regression that can make a straight line up. And
Okay,
then,
I got you.
uh-huh. And there is a
So
strong positive linear relation. That's really wrong. There's no strong one here. The scatter plot depicts constant variance of the GPA across the span of the number. Well, yeah, a lot of variation. Then 1, 2, 3, 4. The last one, it is impossible.
constant would be like if we seen the going straight across, right,
Which
in
one?
one thing, not for the third one. It said the scatter plot displayed constant variance of
Variance.
GPA cost. So that would be like if they was all like around the same thing, right? constant going straight across, like not without all the different
Yeah,
um
yeah, like a 0 hour, their variance about uh their GPA is so different, right? From the
mhm
2.0 to up to someone on the top there. Okay, more than
mhm
4.5. And when you look at the 5 here, visits per hour, this line here, we have visits per hour, but the GPA again different again, right? 3 up to the 4.0. Okay. Uh, not so that's the variance. Okay.
mhm
Rest of the difference, variations. So the last one, it is impossible to determine if a linear model would be appropriate for evaluating relation between GPA and office hour. Ah, oh,
It
that's true.
depends.
Without seeing a histogram on the registers, well, hmm, we don't know about this though. But the linear model, for sure, is not appropriate for evaluating between the GPA and number of office hour. I would say number one is better because the linear model is not suitable for here. Supposed to be
Yeah,
linear, going up like that, but doesn't look like that. Kind of
it's
spread,
all over there. Yeah,
yeah, everywhere about the same height. Okay,
and it
only,
doesn't like make a line, an actual
yeah.
linear line.
Mm-hmm. So I will choose a number one. Okay, the number one, not the appropriate. And number three, you can see a group of the point, right? From the
Yes.
left-hand side, go to the right-hand side. It's not very close to each other, but this graph is different from the previous one. Okay, this one is more like from the left. In general, we have group on the left is lower and go up. On the right side is tended to be upper side. So we still consider, yeah, from the low go up, low, up, higher, low, low point to the higher point. So this one still can show some linear going up. Okay. If you have point from the low on the left-hand side, low part, and you have a group of point on the higher part, we consider there's something going on here, some linear
Okay.
relation. It's not as strong, but still something happening here. And what story is this one? We had to read it. The scatter plot shows the relation between the poverty rate in the 51 states in USA, okay, and the percentage of household with a female head. The average poverty rate is 11.35%, with a standard deviation 3.1, and the average percent of household, 11.63. So they kind of tend to give us more information. They give the standard deviation and the average, okay, the household
Okay.
making money. With a standard deviation, the first one is the average poverty, if 11.35%, then standard deviation is 3.1%. Okay, so just give us some information, idea. And the average percentage household with female had 11.63% of the poverty. Then standard deviation 2.36%, correlation between the two variables 0.53. Which of the below is correct linear model for predicting poverty rate from the percentage of the household with a female head? Okay, so that means in more percent of the female head, well, in one state, okay, and no husband income here, that means poverty is associated. They try to study this. Percent of the
Okay.
female more in one state and then percent correlated with the poverty feminism pool, okay, on the left-hand side there. So let's pick up one point to see what it means that. If I pick up a point on the 8 here,
Okay.
that means less percent, right? Smaller percent of the female household. but 12%, this is state here. Okay, that's present one state. We don't know which is state. Okay, just some state
Okay.
of the United States here. Their percent of the female household got 8%. Okay, almost 8%, and the poverty is 12% high here. Okay, then let's pick another point. This one, wow, that depends on the state, right? This point I pointed here now is more than 8.5% of the female household, but the poverty is not that high. It's maybe about a 5, right? So it depends on the state, right? The state,
Okay.
the richest state, make a difference. Okay. Then let's pick up another point, maybe the point 16 here. 16 here, that means this state, they have 16 percent of the female household here. And the poverty also close to 17%. Okay. So
Okay.
look like um, if the percent of the female household is poverty is higher, also stay on the right side here. Okay. If you look at 18% high of the
Mm-hmm.
female household state, their poverty percent is higher. Okay. Higher than 16%, close to 18%. There's 3 points here. So look at this one, we kind of can think of some slope going up there, okay?
Okay.
Then keep this in mind. The poem already gave you the equation, okay? So you just need to think about, use the concept. Since it kind of tends to go up like that, right? When we increase the percent of the female household to the right, and the vertical line also go up higher, okay? That's positive, increasing. So you have to
Okay.
look at your equation here, looking for the slope with a positive, okay? So only the first equation, right? And the last one, right? The first
Yeah.
one, we have positive 0.7 times female household. 0.7 is positive, okay?
Okay.
And the bottom one, positive 0.4 times the female household, okay? So zero point 0.4 positive, 0.7 positive. Only the first one and the fourth one is possible to be the answer, okay?
Okay.
Now we have to think about y-intercept. Where is the number along itself? That's we call y-intercept in algebra. And that's in statistic here would be the point of in our regression line, we cut the vertical line. So you have to think about it. If I imagine some line passing through here, right? This line going down, we go kind of go below the 6 here, right? We go
Okay.
down. Yeah, that's my guess. It go down. Because if you go up, the line doesn't look like the line we imagine got to go in between among all the points, okay? Straight line. So straight line, I will think about the proper one must be something less than 6, okay? And less than 6, only this one, right?
Yes.
The first one here. The first one is 3.2 with a positive slope. The bottom one, yeah, you can see the bottom one impossible. The y-intercept is 19.49. That's impossible, really. 19 is go up here. Then that means 9 is going this way, going up of all the points. 18 is here. 19 is above the 18. Impossible, right? How can you get the
Yeah.
y-intercept go above the 18 here? No, the line should go below the 6 or close to 6 here. Go up, 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 up like this to cover the right side. So the only choice is number 1. Okay. So this is just testing your concept about the slope and the y-intercept. Okay. And when you go to question 4, you have to use your graphic calculator TID4 to find the
Okay.
regression line. So we can practice together. Okay. So if you know
Okay.
how to do one, you can do the other one. Okay? So let's use a calculator. You have TI-84, right?
Yes.
Okay, very good. So this one just asks you to calculate regression line. Okay. And then we rounded our answer to 2 decimal places. Okay.
Okay. So we're
All
doing
right.
this one just how we normally would do like the regular
Hmm.
linear what
Regression,
is it? Linear,
linear.
yeah, linear
Yeah.
regression.
Yeah,
Okay, so
linear. That's right. So let's go stat. You need to input
okay.
the data first. Okay.
Okay.
When we do chapter 12, you have to input the data first.
So it's that and then like edit, right?
Very good.
To do.
Stat edit and hit the enter.
Okay, and then
So
do L1
so how
and
about your
L2.
L1, L2? Are they empty or you have existing data?
I have stuff in there, but I'm emptying it right now.
If you have existing data, just go up. Okay, go up to the
Okay.
L1 there and hit the clear, then go down. Everything will be erased.
Okay, so now let me put this.
Then go to the L2 and go up and hit the clear and go down. Okay, then will be clear
Okay.
right away. Now you can input your data under the L1 for X. Okay.
Okay, Y.
Okay, 1, 2, 3, 4, 5, 6, 7, 8. There's an 8 pair. So on the side, the Y value put under L2.
Yes. Okay.
You put all the data?
Yes.
Okay, very good. I put mine too. And then now we go to the stat. So hit the bottom of the stat and move to the right side text and go downward to linear. LINREG, linear regression t-test. I hit the enter. Then you can see your screen pop out X listed and L1 is there already. And the Y list column will show L2, right? Then you see frequency 1, don't touch it, just move downward. Then you can see there's a beta and rho. That's for us to do the testing, okay? And for the linear regression test, we always do two-tailed test, okay? So
Okay.
you have to highlight on that not equal 0, okay? And just hit the
Okay.
enter.
So this is always gonna be, I'm always using a two-tail test
Yeah,
for this.
always. With
Okay. Okay.
linear regression, we always assume we don't know is it positive or negative. We don't know. We don't know.
Okay.
We just don't know. Okay. Then always assume not equal 0. Okay. Yeah, we don't know. Because either regression, if we have linear regression, if we have linear correlationship here, it's not equal 0. Okay. And if we don't have, it's equal 0. So only the choice, put the not equal, okay? So then you go downward to calculate and hit the enter, okay? It pop out a lot of information for you.
Yeah.
Yeah.
Okay.
So you are ready to choose y equal a plus bs, the information for the regression line. And remember the problem said, in the parentheses said, each value to 2 decimal places, okay? So I'm going to
Okay.
round A and B to the 2 decimal. And be careful, look at our website here, who made this problem. They put the BS on the front, okay? They put the slope like algebra class. Slope times the X put in the front. And the numerical number only put it up behind. So you have to put the calculator. So you have to read the B first, okay? B attached with the X. So you need to put in negative 1.9. Okay.
Okay, so 2 decimals.
Yeah. Oh, would
2.
be negative 1.9952, your calculator, right? And
Yes.
they say round to 2, then you just round to 2, so it become 5 become going to the 9 will become 10. Then 10 go to the 9. uh, Again, will become the 10, then go up. Oh, so it become negative 2.00. Okay.
Okay, so I just had one question with that. So when I rounded to the second
Oh,
second
you don't have
decimal,
like this, huh? So if you don't, it's good. You just drop this, take the third decimal, right? You
hmm
compare to
okay,
5. If 5, you go up. If not 5, just drop. Okay. Mine
okay,
happened to a number very strange, 995. Okay.
okay,
And then the number shows A on your calculator. You will replace on the last one, last box there, 41.86.
8, 6.
Yeah, mine is 86. So then that's okay. Yeah, 2 decimal. So that's what you do, okay?
Okay.
Now let's go to question 5. Oh, question 5 is also a concept question. Match each
Okay.
scatter plot with four specified correlations. So the R is given to you, okay? The A is giving you R equal negative 0.06, and the B is giving you positive 0.47, and C is positive 0.75, D is negative 0. Negative. So we
Okay.
have to observe the graph you have, okay? The first one, you can see a group of points going downward, right? Your left hand side is
Right, it's
higher.
negative, right?
Yeah, this one should have made sure it's negative, right? So you will look at A or D, but
Okay.
look at, we had to compare another group is negative as well. I think the
Okay.
last one also negative because the left hand side is higher, right hand side is lower, but
Mm.
not very strong because they are very spread around, right? So the one close to the -1 is a stronger negative regression. So the first one, I will choose a D, right? Did
Okay.
you agree? I will choose D. Okay.
So you chose D because
Because
you said
close
it was
to negative,
closer to the one. I mean
yeah,
-1. Yeah,
negative
-1.
1,
Okay.
yeah. When they are going to, from the left go to right, negative direction, going downward, I will choose
Okay.
close to -1, okay? So the D is the right choice. And the last one here, I will pick up the first one,
Yeah.
0.06 negative, A. Because it's going down, but it's kind of spread around, right? The linear
Okay.
correlation very weak.
Oh, okay. So since
Close to
since it spread it
zero.
around like that, that's how I
Yes.
know that it's
Spread
more
around.
further away from
Yes.
one -1. Okay,
Not the
okay, I got
constant
you.
together in one line. Okay.
Okay.
Yeah.
Okay, that makes
That's
sense.
how you look
Okay.
at. Okay. So now
Okay.
you try the other two. Look at the
Okay.
second choice. How do you think? Between the second one and third one, we only have
Well,
two
for the
positive
second one,
left.
I would
Uh-huh.
choose for the second one, I would choose B.
Yeah, very good. Second one, I will choose B. Yeah. And the third one is closer, right? Each other.
Yes. Okay, that just made it so much like clear for me when you explained that part like
Very
that.
good. You got the right choice.
Cause I think I find it like easier like when I'm inputting the data and using like the calculator, but like when it comes to like the graphs, I'll be kind of like confused sometimes. But that
Uh-huh.
just made a lot of sense to me.
Yeah, that's good because the graphing help you to understand better,
Okay.
visualize. Yeah, each number connect to the graph, what it look like. Okay,
Okay.
very good. You got all correct. So let's go to the next one. Next one is the calculate the correlation coefficient. So we will do the same thing we did earlier. Okay,
Okay.
and just looking for R. Okay.
Okay.
And remember to round the 3 decimal. So we do same thing as we did earlier. Okay, so we skip this one. Let's go to the 7. Here is a scatter plot for a set of the bivariate data. And because we have 2 sets of data, X and Y, that's why they use that word.
Okay.
What would you estimate the correlation coefficient to be? Oh, another estimation of your concept. It's kind of,
Okay.
yeah, give it a try. Now you should have better vision to see this
So
one.
I feel like it would be negative from what I'm looking at.
Now you have to compare
'Cause-
the left-hand side and right-hand side. Which side the point is
Oh,
lower? The lower one
oh, the
is
lower one.
going
Okay.
up,
So it's
right?
going up.
Yeah,
Yeah.
yeah, yeah.
The lower one is
So
going up.
you have to
Okay.
pick out the positive one.
Okay, so positive. So
Mm.
anytime I see it and it's the lower side,
On the
the
left-hand
lowest is
side
over the.
is going up.
Okay.
Yeah, it's going up. And
Okay.
make
Okay.
sure right side got some point very high there. Okay.
Yeah.
Yeah.
Okay.
Then your
Then-
choice is between 0.6 and 0.9. Okay. Now
Okay.
you have to compare to think about are they very close or not? Because if the close to the one will be the perfect, will be all the point on the same line in algebra. We all the point on the line. That's a one. That's a positive one. Okay. So you think
Yeah.
about, huh? Are they close enough?
Let me see. I want to say. I want to say it's.
Well, point
It
6,
does look very
point
close,
9.
but then I'm seeing. Yeah, I see. It looks very close because it kind of look like it's going there. I don't really see too much like scattered around. I'm gonna go
Yeah,
with that
there's some
one.
points scattered around. Yeah, so you should choose the point 6, right?
7.9. Oh, it's 0.6.
Yeah, because point 9, they are close. Okay, because
So
point
it'll be a lot
9,
more closer than this one.
oh yeah, point 9 is
Okay.
the one, right? Just point 1
Okay.
will become
Oh
1,
yeah, it's closer to
and 1
one.
is the perfect. It's all the point on the line. Okay.
Okay.
And you point 9, just a few point out only, right? Majority is still on the line. Point 6, wow, you can see when you draw a line, go among them, right? We can
Yes.
capture some point on the line, but not all of them, and not most of them either, right? Okay, now you can draw the line among this one here, but the point 9 should be very close, okay? Should it be,
Okay.
let's see, do we have any graph here? No. In the book, they show you point 9 there. Very close. Very close.
Okay.
Oh, okay.
Kind of like that one
Oh,
right
like
there.
this, like this one. Like
Yeah.
this, like this. Okay, I will say like
Okay.
this one here. Go up and very close. Okay. Or
Okay.
maybe this is a negative one. Almost a negative one. Okay. This is the almost a positive, no, point 0.9. I would say this is positive, point 0.9. Okay. Yeah.
Okay.
The second one is a point 0.9. And the third one is maybe negative 0.95, point 0.9,
Yeah.
yeah, a little bit more than 0.9 something. Okay, so good. After understanding the graphing, you will make the right choice. Okay,
Okay.
then that's the right choice. You have to choose. Yeah, I think the point 6. Okay. And the number 8, I think it's similar, same thing. Just ask you to find the correlation coefficient. Okay, so you can use that one I showed you we did earlier, and just
Yes.
answer about the R. Okay, and number 9 look like the same thing again, but they have one additional question here: R square. And remember, R square is a coefficient of determination, right? Try to
Okay.
determine how many percent of the variation in Y can be explained by the variation in value of the X. When we change X, Y change, okay? And to
Okay.
see how good our regression line, okay? How many percent can be covered, their variation here. So this one, you just look at the calculator. If you still have that work there, when you go downward, I think you can see, yeah. The one we did earlier, when you scroll it
Yes.
down with the down arrow key, you will see R square. You will see the R, okay. So
Okay.
not
So it'll
R
all
squared.
be the same way. Just go scroll down
Yeah,
to find
same
R squared.
way.
Okay.
Just go downward, you will find it. And
Okay.
remember, the R squared usually we present it in percent. So you have to move the decimal point to two space to the right to answer like 8.40%. Okay, like this problem, maybe 8.0. It must be 0.84, but then we give the 1 decimal percent, I'm sorry, 1 decimal percent. So 1 decimal percent means that your decimal, you have to give one decimal only. So this originally should be 0.084. Okay. So they give
Okay.
the 8.4%. Only pick up one decimal. Okay. Move the decimal point to the right, two space. And percent is outside already, so don't touch. So you don't need to put a percent in.
Okay.
And number 10 is also used that the regrade, linear regrade t-test. Use that one. So you will find out what's the R, what's the p-value. Okay. If you look at the one we did earlier, they will show you all the information there. The test is statistical t and also show you the p-value. Just copy that value, put it here.
Okay.
Yeah. Then if you know the p-value, and if the p-value, you just compare to the alpha, okay? If smaller than the alpha, then we can reject no hypothesis. And no hypothesis assume our rho is equal 0. That means nonlinear, okay?
Okay.
So it depends what number you got, then you answer that. So let's see. This one, let's see, the p-value is 0.33, 3326, and our alpha is 0.02. So it's not less than, okay? So if
Yeah.
not less than this number here, we cannot reject no hypothesis. Do not
Okay.
reject. So do not reject no hypothesis. That means there is insufficient evidence. Oh, because no hypothesis, we assume non-linear. There's no linear. Okay. Assume nothing there.
Okay.
Then
So if it's greater than
if you
the
greater than
sigma,
no,
then we gotta.
if the greater, just if less than, only less than we can reject. Okay.
Okay.
Just
Okay.
remember
But if
one
it's
way.
greater, then
Yeah.
it's that means there's no linear.
Yeah. Yeah.
Okay.
In this case is greater, so it's non-linear because we cannot
Okay.
reject. Okay. Then 11. They give you one equation here, regression equation, and then give you the correlation R, okay?
Okay.
And you want to predict that, oh, okay. What is the predicted value? Okay. Predicted explanatory value. Wow.
What is the predicted estimation? So will I get this number by doing using a calculator and input
Oh,
in
yeah.
oh okay.
No, no, you don't go to calculator. You are going to go to the table. I think,
Okay.
yeah, the table statistics table. I posted on the, I think it's linear announcement there. And there's table A6, okay, table 6. That's you are going to compare. If the alpha is 0.01, it's
Mhm.
a table like this, okay? I cut
You
the
said it's an
table.
announcement.
Yeah,
Okay.
let's check it there. Make sure it's there. Let me go to there to make sure. Stop and share. Go to the course. Share. Oh, I just come to the announcement. Let me see, do I put it there or not? Oh, new announcement. Okay. I check announcement here to see if I put it at the table. I didn't put it here. Maybe let's go to the discussion board. Discussion. Last week. Oh, I didn't put up the table. So I need to put up the table for you, for everybody. I think we put announcement here. Because announcement will go to your email account, right?
Yeah, it goes to like my email and then I can see it too when I click on
Yeah,
announcement.
better. So I'm going to put in here, hit announcement and put up a statistical table. Use a table A sheet to find the critical value of R. If absolute value of the R, if absolute value of the R is greater than critical value, then reject. Oh, yeah, then, yeah, you can reject the null hypothesis. Then reject null hypothesis. Um, there is significant linear correlation. We can use linear regression equation for the prediction. Some people ask you to predict something, okay? And if you find that
Okay.
this R is significant, okay, then we can use that equation, just plug in the X and find out the Y, okay?
Okay.
Otherwise, okay, if, otherwise, otherwise, uh, use the Y bar, okay? Use the Y bar for prediction. Since the R is not significant. Okay. So depend how you compare, okay? If when you
Okay.
compare, if the value, the R is greater than the critical value on the table, then we can reject, okay? And we can say, yeah, this is a significant correlation here. And we can use the regression equation for prediction. Okay. So
And that's what the problem was showing us that that we just saw, right? Okay.
yeah. So let me find out the symbol. You can use this one to type when you wanted to show something on the board. Hmm. There's one. You can put the bar on top. Ah, basic. Oh yeah, here. Then I want to do the Y bar, so I put the Y bar down. And we pop out here, Y bar. Mathematical symbol you can use. Okay. All right, this is very important. So I'm going to connect the table and no, from here. And pause my computer. Math 160. We used to call Math 160. And the state law asked us to change to common number for all the state in California. Change the stat 1000. Yeah, because statistics become very become the oh, I found it here. I think this one statistics table. Because statistics become the requirement for all the degree now. So they just want to make it a common number. So student can transfer from one college to another college and make it easier. When they see the same number, approved. No more discussion. Yeah. Oh, Lotus is here. Hi, Lotus.
Hi,
How are you?
good. How are you?
Good. So we are kind of reviewing the chapter 12 because Kiara was alone. So we kind of doing the homework assignment here. And it's good. We went over chapter 12 again, and I discovered I didn't post the table A6. This table A6 is for chapter 12. Okay. So I'm going to save this. Let's save this. Oh, can I save here? My God. There's no button for me to save. Ah, I think the announcement they don't need to save. Okay. Let me make sure. Yeah, you can change. Okay. So this one will send it to all. I hope so. To everybody. Statistical table. Okay. So let me go back to see is there or not. Statistic. And it's here. Okay. Okay. Table is here.
I
Click.
see it.
Oh, good. The table coming out here. So this first table is for G-score. Okay. For the earlier chapter until chapter 5, chapter 6, we needed that. Chapter 7. Then chapter 8. Chapter 8, chapter 9, we needed this table T. And A4 is for chapter 11, chi-square test. And chapter 12, we use this one.
Okay.
Linear regression, A6, okay? So for example, if I have sample data, 6 data, then I look at the right-hand side, I will find the critical value is 0.811 under the alpha 0.05. Sometimes problem will tell you alpha. Sometimes problem will tell you alpha is 0.01. Like that exercise we will look at together, that was a 0.01. Okay. So if 0.01, you just look at the look at the under the 0.01. So critical value is 0.917. Okay. That's how you look.
Okay.
And we only take absolute value to compare with this. So even our problem gave us R negative, you just put the absolute value, ignore that negative sign, and use the positive value compared to the value here. Because our table only shows positive only. Okay. So that's how you do it. So if the R is smaller than the critical value we are looking at here, then we cannot, our linear correlation is not strong, it's not significant, okay? So that you cannot use a regression equation for prediction, you have to use a white bar, okay? That's the only, that's one thing very important for your final exam. I can tell you final exam will come out something like that. Concept asking.
Can we use that for the final exam?
Yeah, final exam, you can use this table and you can prepare this table, okay? You can make a copy, hard copy. Because during the exam, you cannot open another site on the website
Right.
with lockdown. That's why we call lockdown browser. The responders will lock down everything. Doesn't allow to go outside of our exam site. So that's why you need to make a copy, hard copy, okay?
Okay.
So you can write a note to remind yourself, okay? So let's get out of here. This is all the tables you need. So if you need the other table, you can make all the copy too, okay? But if you have graphing calculator, actually, TI-84, we don't need the earlier table here. What we need only the A6. Your A6 is not in the calculator. Okay. All right, so let's share again. Go back to the question view. Oh, actually, I was in that side. Huh. So, I was in that side, was correct. I just go to the table.
The only question I have is, will I have access to the study guide for the final exam before I take it?
Oh, yeah, going to take exam earlier, right?
Yes.
Yeah, I remember that. So yes, email me.
Okay, I'll send you
Remind me tonight, okay?
No
So
worries,
I will post earlier for you. Okay.
Okay, perfect.
Yeah.
I'll send you an email.
Yeah,
Thank you.
send me email now.
Okay. Well,
yeah, that's a good reminder. Okay, so I'll share this one, but this one I cannot go back. So I better open another one. Let me open another one. One more keywords. Okay. So we go back to chapter 12. And so chapter 12, you have to pay attention to that. Okay. You have to take the R compared to compare. Oh, but for this problem, let me see another problem similar to here. Oh yeah, there's another one there. For this problem, a little bit tricky. What's the problem here? Number 11. It says you want to predict what the value, but this value is for explanatory, for X, not for Y. Okay. Usually we ask you Y, right? What is the Y? Predicted value Y, and we just plug in the X and get a Y. Okay. But before you check the critical value first, only greater you can plug in. If the smaller, don't do it. You have to choose the Y bar. And the question should give you some white bar there, okay? But this problem, you can see there's no white bar here. So you have to be alert already. Because the question is asked to find out the x. X equal what? To make we give you a value 90 of the response variable. That means we give us the y as 90, okay? But the x is what you need to find out. Okay. So for this problem, since they did not give us anything, oh, they give the 82. You see the sample size of 82, so large number. So where is my table? Let's see my table here. You can open a statistical table, and I found out my 80 critical value is under the alpha 0.01 is 0.286. Okay. So, and the R on this problem is 0.335. So absolute value of this R is greater than the critical value. So that's why we can use the regression line for prediction. It's okay. Okay. That's why they show you that the R. So remember to compare with the table A6. Okay. So after you find this one, what you have to do, I think I will show you the whiteboard now because if you're just talking, you don't understand what I'm saying. So let me copy. Okay. Huh. Then pop out. Okay, pop out. Okay, so I'm going to stop share all this one and share the whiteboard. The whiteboard is here. Share. Okay. Did you see it?
Yes.
Whiteboard? Okay. Good.
Yes.
So to solve this problem, you have to be very careful because this problem give us the y first, okay? We give you a value of the 90, okay? So what you do, you have to replace the y by 90, okay? Now the equation is there, y equal negative 2.087x minus 14.948, right? So you replace y by 90, okay? Then copy the 2.087x and minus 14.948. Okay, just copy that equation. And remember, this one just look like an algebra problem, okay? And out in algebra class, algebra 1, algebra 2, when problem give us some value of the y, you replace y and ask you to solve for x. So to solve for x, you just need to put all the variable on one side, right? Numerical number other side. So what I will do, I will move this x to the left-hand side, okay? Just like a plus 2.87 x here, cancel this one and add to the left-hand side. So, and the quick way, just switch around all the equal sign and remember change the sign. So it become 2.087x, okay? Go to the left-hand side and change the sign, become the positive. And the right-hand side, I will move the 90 to the right side and together with the numerical number. And the right side, I already have that negative 14.948. So bring over that 90 to the right side. It's just add on negative sign for 90. And you can bring over. This is shortcut way of your solving equation in algebra. Then you just need to combine like a term, right? X equal, and you just need to combine these two negative number, 14.948, adding with a 90, they're both negative, so you add together as a negative 104.948, okay? Then remember how to solve equation? We just need to divide, right? Divide out. So I put the underline. Oh no, this one doesn't let me to do that. So understand, I'm going to divide, okay? Or maybe I put some explanation here. Okay. Divide both sides by 2.087, right? Obtain x equal. So you will have negative. You will have negative divided by positive will be negative, right? You will have 104.948 divided by 2.087. Like this. And you should have come out the answer already. If you have calculator there, oh, I forgot my negative sign, negative. So the answer will be 104.948 divided by 2.087 and become negative. Our answer should be negative. Negative 50.2865. But I think they want us to round to whatever rounding, okay? If they want you round to 3 decimal, you just round to 3 decimal. And look like whatever they ask you, you do it, okay? Just read the instruction, what you have to do for rounding. Okay, so that's how you got the x here. Okay, put the x here. For this problem, you have to be careful because the problem give you the y first. Y is the one we call response variable. And we are looking for explanatory. Explanatory is x, okay? Usually some student will make a mistake, put the x, replace x by 90 and get an answer. It's not what we need, okay? So be careful with this question 11, and very tricky. And the others is similar to each other, okay? So today, at least I help you to solve some chapter 12 homework questions. And we still have one meeting next time, right? Next week, I think. Today, yeah, today, before the Thanksgiving, yeah, December 3, we still meet here, okay? Maybe our last meeting before the final exam. Oh, we have one more time, maybe December 10. So December 3rd, the next week, we can do chapter 13, okay?
Okay.
I can help you to do the ANOVA test, okay? Then
And then you said we'll be getting a study guide.
Study guide, I think I will post tonight because we have some students need to take the final exam earlier. So
Okay.
I'll post tonight. Okay. After we finish this.
Thank you.
You're welcome, Lourdes, and good luck. And try to finish all the study guide, okay? And
Yes.
this solution at the end of the page. Remember to check your answer. So if
Okay.
your answer is different, then you post on the discussion forum, okay? I will open that one too, okay? And so you can post there. You're posting there. You got your credit for participation 10 points, okay? So it's
Okay.
good. Ask question and get the 10 points. And then among all the review exercise there, if you know one of them, you know how to do right, you check the answer is correct, you post a complete solution, okay, you will get another 10 points. And this 10 points is extra credit adding to your final exam score. If you got 150 with a 10 point more, it will be 160 like that, okay? Your exam score with 10 points more, like a midterm exam. All right?
Okay.
Perfect.
Yeah, so good luck, Lourdes, because you are going to take exam earlier, right?
Yeah.
Okay, so just prepare earlier, then you're okay. And our homework is chapter 13, only 5 questions only. So make sure finish that. Okay. All right, so see you all next.
Happy Thanksgiving. Thank you.
You're welcome.
Okay. Thank
Yeah.
you. Happy Thanksgiving.
Yeah, happy Thanksgiving to all you.
Bye.
Bye-bye.